Section 4.4 talks about how to multiply polynomials. So, excuse me, in essence what we're doing here is we're going to be using the distributive property. So let me grab my pen here and we'll start. We're going to go 4x squared times each of those terms. So let's go slowly here. So we already know that 4 times 6 is going to give us 24. If it helps, I want to remember that the power on that x is a 1. Remember, now we're going to add our exponents. So 2 and 1 more is going to give me 3. Minus, because there's a minus here. Well, 4x squared times 1 is just 4x squared. These are not like terms, so I can't combine them. I'm going to just stop right there, okay? Let's try to do the same thing with the next problem. So we're going to go 1, 2, 3. So 5x to the third times, I can think of that as a negative 1x squared, would give me a negative 5x to the fifth. 5x to the third times 3 would give me a positive 15x to the power 4. And 5x to the third times 2 would just give me a 10x to the third. Again, none of them are like terms, so we stop right there, right? Alrighty. So the next one, guys, let's think about everything here as a fraction. So I'm going to think of each of these numbers as over 1. And we're going to go just in slow motion. We're going to do the top numbers, okay? So 2 times 4x would give me an 8x. 2 times 6x squared would give me a 12x squared. And 2 times negative 2x to the third would give me a negative 4x to the third. Now I'm going to take my bottom number. I'm going to multiply them all by 3. And then we will simplify anything we can. So 3 does not go into 8, so I'm going to leave that alone. 8x over 3. But 3 does go into 12, goes in 4 times, so that's a 4x squared. 3 does not go into 4, so I'm going to leave that one alone, minus 4x to the third, okay? Again, none of these are like terms, so I'll leave my answer as it is. Okie dokie. And let's try the next two. So I'm going to grab a different color. Let's go with red. 1, 2, 3, 4. Okay, so 6 times 2 is going to give me 12. Remember, we're adding our exponents. That's an x to the 7th. If it helps, think about that as a negative 1. So 6 times negative 1 would be a negative 6. Again, adding the exponents will be 5. 6 times 3 is 18. Again, if it helps, think of that exponent there as a 1. 3 and 1 more is 4. And finally, 6 times 9 is 54. X to the third. Again, none of them are like terms, so we'll leave our answers like that. And one more on the same page. 1, 2, 3. So let's see. That's going to be a negative 16x to the 6 and a positive 10x to the 5. And negative 2 times 6 is a negative 12x to the fourth. All right, let's go on to the next page. All right, so let's take a look at the next problem. And what we're going to do, guys, we're going to use the distributive property twice. So I'm going to take this x, I'm going to multiply it by both those terms. So we already know that x times x is going to give us x squared, and x times 7 is going to give us a 7x. Okay, guys, I've already used that x, so I don't need to use it anymore, but I'm going to do the same thing with the number 5. So 5 times x will give me a 5x. 5 times 7 will give me the number 35. If you notice, we can actually combine those middle terms. So 7x and 5x, guys, remember when we're combining like terms, we're just adding the numbers. The exponents do not change, okay? So they're still going to stay x's. So 7x and 5x is just 12x, okay? Alrighty, let's try the next one. Let's go about it the same way. So x times x is going to give me, again, x squared. X times 3 will give me a 3x. Now we've already used that. Let's do our number 9. So 9 times x is 9x. 9 times 3 is 27. Okay. 3 and 9 will add up to the number 12 plus 27. So we have x squared plus 12x plus 27, right? Okay. Let's go back to red. 1, 2. So again, x times x is x squared. X times negative 4 is a negative 4x. Okay. Guys, I want you to look at this number. I'm thinking about that as a negative 5. So negative 5 times x is a negative 5x, and a positive 20, because a negative 5 times a negative 4 is a positive 20. And let's see, if we combine these two here in the middle, that's going to be a negative 9x plus 20, right? If I owed you $4 and I borrowed another 5, you would tell me, hey, now you owe me 9. Righty. So continuing, 1 and 2. So let's see, 5x times negative 4x is a negative 20x squared. Okay. 5x times negative 3 is a negative 15x. So I've used that one. So negative 2 times negative 4 is a positive 8x. Negative 2 times negative 3 is a positive 6. Okay. So again, that one's going to stay by itself, negative 20x squared. We can combine these two together. If I owed you 15, but I only paid you 8, I would still owe you 7. And then we still have that plus 6, right? Good. All right. So let me grab my marker again, or my pen again. So 4y times 5y is a 20y squared. 4y times negative 3 is a negative 12y. Plus 5y, because we're multiplying them by 1, minus 3. So let's take a look here. We got a 20y squared. Again, we can combine these two together. If I owed you 12, but I only paid you 5, I would still owe you 7. And then a minus 3. Right? Alrighty. So the last problem here, let's take a look. Again, we're going to go in slow motion. 5 times 2 is 10. Remember, we're adding the exponent, so that's going to be x to the 4th. 5 times 3 is 15, but I want you to notice the exponent or the variables are different. One's going to be an x squared y to the 3rd, right? So now that we've taken care of this guy, let's multiply the negative 4, or the positive 4, I'm sorry. So 4 times 2 is an 8. Notice my variables are still x squared and y to the 3rd. Sometimes people ask, why am I putting the x squared first? Simply alphabetical order, okay, guys? And then finally, 4y to the 3rd and 3y to the 3rd would give me a 12y to the 6th. The other reason I want to write them in order is I want you to be able to realize that those are actually like terms, right? So we got a 10x to the 4th. 15 plus 8 is 23, x squared, y to the 3rd. And then finally, plus 12, oops, there we go, y to the power 6. And that is section 4.4.